Imagine a scenario both terrifying and awe-inspiring. A cosmic event of unimaginable scale catapults Earth from its solar cradle. Our home, the once vibrant blue planet, becomes an interstellar wanderer. This is the story of a rogue Earth, adrift in the vast cosmic ocean. A rogue star larger than our Sun enters the solar system. Its gravitational pull wreaks havoc on the delicate orbital balance. The outer gas giants are the first to feel its effects. Their orbits are perturbed, sending them careening through the solar system. The inner planets, including Earth, are caught in a cosmic tug-of-war. The once predictable dance of our solar system descends into chaos. Will Earth survive this cosmic game of billiards? Or will it be flung out into the cold, dark void of interstellar space? The universe, for all its beauty, is an inherently violent place. Catastrophic events, while rare on human timescales, are not uncommon on cosmic ones. Several such events could potentially eject Earth from its solar system. One possibility is a close encounter with a wandering star. These stellar nomads drift through the galaxy, their gravitational influence capable of disrupting entire planetary systems. Another scenario involves the passage of our solar system through a dense region of interstellar gas and dust. These regions, often referred to as molecular clouds, exert a gravitational drag on orbiting objects. Over eons, this drag could gradually alter Earth's orbit, eventually flinging it outward. A more dramatic possibility is a galactic collision. Our Milky Way galaxy is on a collision course with the Andromeda galaxy. A galactic merger could send stars and their planets scattering like dust in the wind. The ejection of Earth from the solar system would have profound consequences for life on our planet. In the immediate aftermath of our solar system's disruption, Earth would experience a period of intense geological upheaval. The gravitational forces of the rogue star would tug at our planet's crust, triggering massive earthquakes and volcanic eruptions. Tsunamis of unimaginable size would wash over continents, reshaping coastlines in an instant. As Earth is flung away from the Sun, the temperature would begin to plummet. The oceans, no longer warmed by the Sun's rays, would gradually freeze over. Ice sheets would spread from the poles towards the equator, encasing the planet in a frozen grip. The atmosphere, too, would undergo drastic changes. Carbon dioxide, no longer absorbed by plants, would build up in the atmosphere. The once vibrant blue planet would transform into a desolate, frozen wasteland. But even in this harsh new reality, life would find a way to endure. As Earth hurtles away from the Sun, the once familiar day and night cycle would cease to exist. The Sun, now a distant pinprick of light, would offer no warmth, casting the planet into perpetual twilight. The temperature would plummet rapidly. Without the Sun's energy to drive the water cycle, precipitation would become a rarity. The once lush ecosystems of Earth would wither and die. The oceans would begin to freeze over, starting at the poles and gradually creeping towards the equator. The frozen surface would reflect what little sunlight remained, further accelerating the cooling process. Within a few years, Earth would be a snowball planet, its surface locked in an icy grip. The atmosphere, too, would undergo a dramatic transformation. The once protective ozone layer would dissipate, leaving the surface exposed to harmful cosmic radiation. But life, tenacious and adaptable, would find a way to cling on in this frozen wasteland. With the surface of Earth rendered uninhabitable, life would retreat underground. Here, in the planet's geothermal warmth, a new kind of biosphere would emerge. Geothermal vents, spewing heat and chemicals from Earth's core, would become the primary source of energy. Chemosynthetic organisms, capable of converting these chemicals into usable energy, would form the basis of this new food chain. Caves and underground aquifers, shielded from the harsh conditions on the surface, would become havens for life. These environments would be home to a diverse array of extremophiles, organisms adapted to thrive in extreme conditions. Blind cavefish, already adapted to life in darkness, would flourish in the subterranean lakes and rivers. Their heightened senses of touch and smell would allow them to navigate the dark waters and locate prey. Fungi, too, would play a vital role in this subterranean ecosystem. These decomposers would break down organic matter, recycling nutrients and supporting the growth of other organisms. Life on a rogue Earth would be a testament to the power of adaptation and the will to survive. In the abyssal darkness of a sunless Earth, life would embark on a new evolutionary trajectory. With no sunlight to provide energy, photosynthesis, the cornerstone of most surface ecosystems, would cease to exist. Instead, life would rely on chemosynthesis. Chemosynthetic organisms, already present in extreme environments like hydrothermal vents, would flourish. These organisms derive energy from chemical reactions, converting inorganic compounds into organic matter. Over millennia, evolution would favor organisms adapted to the dark, cold, and nutrient-poor conditions. Creatures might evolve bioluminescence, using it for communication, hunting, or attracting mates in the perpetual darkness. Others might develop heightened senses of smell, touch, or echolocation to navigate their surroundings. The lack of sunlight would also have a profound impact on the physical characteristics of life. The pace of evolution would accelerate in this new environment. In the absence of the sun's energy, life on a rogue Earth would face a constant struggle for survival. The primary source of energy would be Earth's internal heat, radiating from its core. Geothermal vents, spewing hot water and dissolved minerals, would become oases of life in the otherwise frigid environment. Chemosynthetic bacteria, the primary producers in this ecosystem, would convert the chemical energy from these vents into organic matter, forming the base of the food chain. However, geothermal energy alone might not be sufficient to support a diverse biosphere. Another potential energy source is the planet's internal heat, which could be harnessed through geothermal power. This would require advanced technology, far beyond our current capabilities. But on a rogue Earth, where survival depends on innovation, such advancements might not be out of reach. Another possibility is the harnessing of energy from radioactive decay. The survival of life on a rogue Earth would depend on its ability to adapt and innovate. As Earth drifts through the vast expanse of interstellar space, it would be exposed to a new set of challenges and opportunities. The most immediate threat would be the interstellar medium itself. This diffuse cloud of gas and dust, while incredibly thin, would pose a constant bombardment of high-energy particles. Earth's magnetic field, already weakened by the loss of the solar wind, would offer little protection. However, this interstellar journey would also expose Earth to a wealth of new materials. Interstellar space is sprinkled with clouds of gas and dust, the remnants of dead stars. These clouds are rich in heavy elements, the building blocks of planets and life. As Earth passes through these clouds, it could accrete new material, enriching its own composition. This cosmic odyssey would also present opportunities for exploration. Unbound by the constraints of a solar system, humanity could launch missions to nearby stars and planetary systems. The ejection of Earth from the solar system would be catastrophic, but not necessarily the end of life. In the Milky Way galaxy, there are billions of stars, many orbited by planets. During its journey, Earth could encounter another star system. The probability is small, but not impossible. If close enough, Earth could be captured by a new star's gravity. This new sun might not be like our own. It could be a smaller, cooler star, or a larger, hotter star, posing new challenges. If Earth found a new home, life could flourish anew. The possibility of a rogue Earth raises intriguing questions about life in the universe. Astronomers estimate billions of rogue planets wandering the galaxy untethered to any star. These planets, once thought barren, are now considered potential candidates for life. Life on a rogue planet could be powered by geothermal energy and chemosynthesis. These processes support life in Earth's extreme environments, providing energy for a subsurface biosphere. Discovering life on a rogue planet would profoundly impact our understanding of life in the universe. It would show that life can exist in the coldest, darkest corners of the galaxy. Studying rogue planets offers a unique window into the diversity and resilience of life. The prospect of Earth becoming a rogue planet is a stark reminder of the fragility of our existence. It forces us to confront the possibility of a future where our planet is no longer a safe haven for life as we know it. However, it also highlights the incredible tenacity of life itself. Even in the absence of sunlight, in the depths of a frozen world, life could find a way to endure. The vastness of the cosmos is both humbling and awe-inspiring. It is filled with dangers but also with possibilities. The ejection of Earth from the solar system would be a tragedy, but it would also be an opportunity for a new beginning, a chance for life to evolve and adapt in ways we can only imagine. The story of a rogue Earth is a story of survival, of adaptation, and of the enduring power of life. It is a story that reminds us that even in the face of unimaginable challenges, hope remains. For as long as there is life, there is a future.